Balloons are a common sight at celebrations and decorations, available in various shapes, sizes, and colors. In earlier times, they were made from dried animal bladders. Imagine those at a party. However, this didn't remain the norm. In the 19th century, rubber balloons were introduced, eventually giving way to latex balloons. Latex became the preferred material due to its incredible elasticity, capable of stretching up to 7 to 8 times its original size. This made it an ideal choice for balloon production. Today, the balloon industry is valued at approximately $300 million US. But how are balloons made? It all starts with raw natural latex, a white or yellowish opaque liquid resembling milk. Latex is a secretion from specific plants, primarily the hevea tree, originally found in Brazil. Nowadays, the most significant sources of natural rubber come from plantations in Malaysia and Africa, where rubber producers carefully harvest this valuable material. The raw material for balloons comes from rubber trees, where skilled workers, known as tappers, carefully extract latex. Using special tapping knives, they make precise incisions in the bark, allowing the milky white latex sap to flow into collection cups attached to the trees. Over several hours, the latex gradually fills these cups. Tappers typically return every 1 to 3 days to collect the sap, depending on factors such as tree health and climate. Once collected, the latex undergoes treatment to prevent coagulation, which would make it unusable for further processing. To maintain its fluidity during storage and transportation, ammonia is commonly added as a preservative. In balloon production, various additives are mixed into the latex to enhance its properties. Antioxidants help prevent degradation from exposure to air and light, while vulcanizing agents promote cross-linking of polymer chains during curing, improving elasticity and durability. The latex undergoes a concentration process to remove excess water and increase the concentration of rubber particles. This is achieved through either centrifugation, where the latex is spun at high speeds to separate solids from liquids, or evaporation, where heat is applied to remove water. Once concentrated, the latex is transported from production facilities to balloon manufacturing plants using specialized containers or tanker trucks. During transportation, careful measures are taken to prevent exposure to extreme temperatures or mechanical damage, which could compromise its quality. At the factory, the latex is mixed with dye and filtered through cheesecloth to remove any lumps. Agitators at the bottom of the mixing tank continuously stir the latex for 15 hours. This factory produces balloons in as many as 53 different colors. The molds used to shape round balloons resemble neatly arranged upright baby rattles traveling on a tray. They are typically set in a grid formation, such as 3 rows of 11 molds each. As the tray moves through various stations, some contain special fixtures that flip it, allowing the molds to be dipped into different chemical solutions. Before this process begins, the balloon molds are first sprayed with hot water and cleaned as they pass through a system of rollers. Next, they are flipped and dipped into a tank of coagulant. This coagulant contains an electrochemical charge, which helps attract the colored latex solution when the molds are submerged in it. As a result, a thin, uniform layer of latex coats each mold, forming the base of the balloon. The longer the molds remain submerged, the thicker the balloon walls become. The longer the molds remain in the latex tank, the thicker the coating becomes. However, since balloons require a very thin layer of latex, the molds are immersed for only a few seconds. To ensure an even coating and prevent air bubbles, the insertion and removal speeds are carefully controlled. Next, the coated balloon molds travel along a conveyor towards spiraling brushes. These brushes roll up the bottom edges of the balloons, forming the signature lips. These lips make it easier for people to grip and inflate the balloons. Afterward, the balloon molds are dipped into a hot water bath. This step is crucial as it removes proteins from the latex that can cause allergies. Additionally, the heat initiates vulcanization, a process that strengthens and rubberizes the latex, enhancing the durability and elasticity of the balloons. The vulcanization process, discovered entirely by accident by Charles Goodyear, revolutionized the rubber industry. It significantly improved the elasticity and durability of rubber. Before vulcanization, raw rubber was soft, sticky, and prone to deformation under various conditions. However, after undergoing this process, rubber became more resilient and capable of withstanding greater stress, making it suitable for a wide range of applications. The next step in balloon production is stripping the balloons from the molds. To make this process easier, the molds are dipped into a mixture of talcum powder and water. This coating helps the balloons slide off smoothly. Finally, as the molds pass through a specialized machine, air jets inflate the balloons slightly, helping to loosen them. As they expand and begin to detach from the molds, rollers at the top grab the balloons and roll them away, completing the molding process. Once stripped from the molds, the balloons fall onto a conveyor belt, where a worker gathers them and loads them into an industrial washing machine. A cleaning solution is added, and the machine heats to 71 degrees Celsius. This process not only cleans the balloons, but also completes the vulcanization of the latex, ensuring their strength and elasticity. Afterward, the balloons undergo rigorous pressure testing to ensure they can withstand inflation without bursting. This involves inflating them to their maximum capacity and exposing them to specific pressures for a set duration. Quality control also includes checking for color consistency across batches to meet customer expectations, ensuring that every balloon maintains a uniform appearance and durability. The balloon manufacturing environment must be strictly controlled to ensure high quality and consistency throughout the production process. Computer-based instrumentation monitors and regulates key factors such as air humidity, air temperature, latex tank temperature, and the temperatures in ovens and dryers. The latex and other chemicals used in production are carefully formulated for specific properties and must be meticulously maintained. For example, the latex must have a precise viscosity and drying speed. Tanks holding the latex are equipped with circulation systems to prevent skin formation and ingredient settling. After passing quality control checks, balloons are sorted and packaged according to customer requirements. Packaging may involve individually wrapping each balloon or grouping them into sets. Once packaged, the balloons are stored in controlled environments to maintain their integrity, and careful handling during transportation ensures they remain undamaged and retain their shape. So, the next time you're at a party and see a balloon, you can truly appreciate the amount of work that goes into making one. If you enjoyed this video and want to see more, be sure to check out our channel.